Hey everybody, today we're gonna learn more deeply how machine learning, deep learning, or so-called AI memorization happens. And the first example that we're gonna explore together is repetition. So this week is all about highly repeated examples. So if you remember the distribution, we have again normally this kind of long tail distribution when we collect data at scale. And in that head of the long tail, we have really common, highly repeated images, videos, text, audio. So, highly repeated examples get memorized quite quickly in these systems. What do I mean by that? Well, for example, if I take any online tool to generate AI images or this is one of the easy generative AI online tools you can use. I can type in Angela Merkel and I can get an image that we can recognize as humans as her face. So this is one example of clearly memorization happening. The model has learned how to repeat a specific name into a specific face and likely vice versa. And this is kind of one way of memorization. Another thing that I can do is I can get ChatGPT to read me a book. A simple short children's book like Dr. Seuss's Cat in the Hat is something that I can get the entire text word for word if I just continue asking ChatGPT, continue where you left off, continue where you left off until the book is done. There's likely many other examples of this, but one other example that doesn't require more than one prompt is to get the Zen of Python, which if you've ever used the Python programming language, is kind of a known poem. And so these are all examples of something that's memorized, right? We can repeat it in a way that we can all recognize. We can repeat it word for word. We can repeat it facial dimension by facial dimension. We can also do this with audio and video. And you might be thinking, yeah, but this is what we want it to do. If we train generative AI, maybe we want it to be able to read a book. Maybe we want it to be able to reproduce a very well-known face or image. And that's true. So perhaps this memorization, this highly repeated example memorization, is indeed expected and is even desired. And what has been shown with this type of memorization is that with larger model size, we get more memorization. Here's some research from Google that looked at what they call K-Eidetic memorization, which is essentially when we take one text and then we continue it. How many of those tokens can we extract in a row that's the exact same as the training text? And here we can see that we have the larger models on the left side, we have the initial prompt on the farthest left side, and then we have the continuation. The largest model, 6 billion, then 2.7 billion parameters, and so on. And we can see that the larger the model size here, 6 billion parameters, we can get a word for word matching continuation. And as the model size gets smaller, we don't get a word for word continued or a token for token. We get maybe pieces or portions, but there's much more randomness in between. And this is proven time and time again. The larger the parameter size, the more of a propensity to memorize. And so again, we can ask ourselves, is this expected? In this case, we're looking at also code. Do we expect a language model to write word for word or token for token code that it's seen? This is an interesting question because the same question comes up if you use GitHub Copilot. Now, I think by default, GitHub Copilot disables suggestions that exactly match public code under certain licenses, but you can actually turn that off. And you can turn it off as an entire organization. And what I want us to start thinking about is even if something is repeated numerous times, are there going to be examples that we don't necessarily want to memorize from that group? And if so, how do we reason about which of the highly repeated examples we want to memorize and which ones we don't want to memorize? This is still very debated, as you can see with Copilot, and in the way that AI products are released. And certainly will be an important concept from a legal aspect of what should be repeated, what should be protected from repetition. And you might be wondering how this happens. So, obviously, in this week's article, I'm summarizing here. So, I encourage you to read the article in its completion. So when we think about many of the models that we use today to do generative AI, not all of them, but many at least of the text-based ones are what we call sequence-based deep learning models. And these sequence-based take a sequence as input and then predict a sequence. And as the sequence is predicted, what's predicting becomes a part of the prompt, the input. So as you get the initial prompt, and then as GPT or whatever model is being used continues, it takes the answer that it's writing as part of the input and continues essentially this sequence to next word, sequence to next token. And part of why memorization happens for these transformer models is that there's a particular function or mechanism within how these work that unlocks better language prediction. And that's this attention mechanism. And this is a graphic from the original attention paper. Attention is all you need. And it looks at the fact that when you are looking at this attention mechanism in the model, and you can connect essentially we'll say the concentration of the attention between all of the different tokens that were predicted, we can see that the attention mechanism has learned or stored, or in some cases we can think of this as memorize, that law is related to its is related to application. And when we think of a text like Dr. Seuss, we can think of when it says, I cannot do that, Sam, I am, right? Or something like this. Sorry, I forget the exact phrases, but there's commonly repeated phrases. And you can imagine that these attention weights, that the connection between these tokens have been essentially at that point in time, seeing it many, many times. Again, also seeing the training data itself hundreds of thousands of times, that this is essentially a encoded pathway. And this is exactly why I have such a problem with the Hamburg Data Protection Authority presuming that embeddings reduces the ability to learn or store person-related information, because that is by default not the way that these networks work. Instead, common, repeated connections between tokens will be memorized and will be repeated, because that is exactly what we want when we have an attention mechanism and when we also have a deep, highly parameterized model. Those are the exact outcomes. They are the expected outcomes that we are looking for when we train these models. I'm curious to hear from you. So in the comments, if you wouldn't mind, share, what do you think? What should we repeat? What should we not repeat? Do you think that people, even famous people, should be allowed to opt out of the generation of their face or their voice or their likeness? How do you think about these problems? I look forward to continuing the conversation, and I'll check out the blog post in the article if you'd like to learn more.